Hello, today we're going to talk about the Boolean expressions and if-else statements. So the general form of the if-else statement is the equation below, and where condition is a logical expression, the parentheses around the condition are required. When an if-else statement is executed, the program evaluates the condition and then executes statement A1 if the condition is true, and statement B1 is executed if the condition is false. When if is coded without else, the program evaluates the condition and executes statement 1 if the condition is true. If the condition is false, the program simply skips the block of the statement under if. If there are more than one conditions, you have to use the else if statement in order to fit in the condition 2. If the first if with the condition 1 is not evaluated is not executed, and it moves on to else if, then it moves on to else. Then Boolean expressions are made up of Boolean variables, relational operators such as less than or equal to, and logical operators. You can assign the value of any Boolean expression to a Boolean variable. For example, Boolean over 21 and equals age bigger than 21. Here, over 21 gets a value of true if age is greater than 21, false otherwise. This is essentially a more concise version of the following example below. In Java, there are 6 relational operators: greater than, less than, greater than or equal to, less than or equal to, is equal to, and is not equal to. The result of a relational operator has the Boolean type. If you apply equal and not equal operators to objects, then instead of comparing the values of two objects, you will be comparing two references to them, that is, their addresses. This is a potential source of bugs. For example, the equal operator in string file name, if file name equals words.txt, compares the addresses of the string object file name and the string object that represents a literal string, words.txt. Their addresses are more likely different, even though their current values may be the same.
Java has two binary logical operators, and or, and an array logical operator, not. They are represented by the following symbols. The expression condition 1 and condition 2 is true if and only if both condition 1 and condition 2 are true. The expression condition 1 or condition 2 is true if condition 1 or condition 2 or both are true. The expression not condition 1 is true if and only if condition 1 is false. According to De Morgan's laws, not P and Q has the same Boolean value as not P or not Q. Not P or Q has the same Boolean value as not P and not Q. For example, not fun and games is the same as not fun or not games. These two properties are called De Morgan's laws. They come from formal logic, but they are useful in practical programming as well. In Java notation, De Morgan's laws take the following form: not P and Q is the same as not P or not Q. Not P or Q is the same as not P and not Q. A programmer may choose either of the equivalent forms. The choice depends on which form is more readable. In general, all unary operators have higher precedence than binary operators, so unary operators, including not, are applied first. You have to use parentheses if you want to apply not to the entire expression. The rules of precedence for operators are in the table on the screen. In the absence of parentheses, binary operators of the same rank are performed left to right, and unary operators right to left. For example, double int x is the same as double int x. If in doubt, please use parentheses. In and or operations, the left operand is always evaluated first. There may be situations when its value predetermines the result of the operation. For example, if condition 1 is false, then the value of the expression condition 1 and condition 2 is false, no matter what the value of condition 2 is. If condition 1 is true, then condition 1 or condition 2 is true. If the value of the first operand in a binary logical operation is sufficient to determine the result of the operation, the second operand is not evaluated. This rule is called short-circuit evaluation. A different situation occurs when a program requires true hierarchical branching with nested if-else statements, as in the decision tree on the screen. For example, in this code, if the age is under 25, then it executes the statement inside the if statement, even though the statement itself is an if statement. If the age is over 25, it executes the statement inside the else statement, which also has an if and an else. This would be an example of a nested if-else statement. Thank you for your time. That was our presentation.